Hello everyone, I am Teacher May and I'm going to be discussing the null set, also known as the empty set, and the cardinality of set. Today we're going to illustrate null set and then the cardinality of sets. So going back to the null set, also called as the empty set, this is a set that contains no element. So it is denoted by a curly braces. We have an open and then close braces. Or you can write it as 0 with a dash through it. Okay, so for example, a set of months, we have the set of months whose names begin with E. So of course, we all know that there is no month that begins with E. Then another one, the set of months with more than 31 days. Okay. And we all know that there is no months that begins or that is more than 31 days. So, let us now proceed to cardinality of sets, wherein when we see cardinality of set, this is the number of elements contained in a set. So we have a finite set. It is a set having a fixed number of elements, or it is a set with finite cardinality. So meaning to say, the number of elements in a set can be counted. Let's see an example. Let's say we have in set A, we have 2, 4, 6, 8, and 10. So the cardinality of set A is 5. And there's 5 elements in a set. So that's finite cardinality. So the cardinality can be written as n of A equals to 5. Another example, okay, we have, so this is number 1 example, or letter A. And then let us have letter B example. Number 1 example. And then number 2 example, let's say we have set B. We have elements 1, 2, 3, 4, 5, and so on and so forth, up to 99. So what's the cardinality of set B? So remember that the cardinality is number, or is the number of elements in the set. So how many numbers are there in this set? So as you can see, from number 1, 2, 3, 4, 5, and so on and so forth, up to 99. So the cardinality of this set is denoted by n of B equals to 99. So there are 99 numbers inside this set. Okay? So that's number 2. And this is number 1. So we call this as the cardinality of set. Okay, now next is the infinite set. Okay, so when we say infinite set, this is a set in which the number of elements cannot be counted or determined. So that's infinity. Okay, so it is a set with infinite cardinality. A set with infinite cardinality. So meaning to say, the number of elements in the set cannot be counted. So let's say for examples, we have set C. Let us have number 1. We have set C, wherein we have elements 1, 2, 3, 4, 5, and so on and so forth. So notice that there's nothing after that, and it keeps going on and going. So what do you think is the cardinality? So in this set, we can say that the cardinality of set C is infinity or cannot be determined. That's infinity. Okay? Another example of an infinite set is that let's say set D, we have x such that values of x or x such that x is a positive odd numbers. Okay, so as you can see, this is in a set builder notation. So we have here the cardinality is what? It cannot be determined because there are infinite positive odd numbers, right? So here the cardinality of this set is that infinity or cannot be determined. Okay, so we all know the difference between the finite set. Okay, we have the finite set and then the infinite set. Okay, let us have an example. Let us illustrate the cardinality of set and tell whether it is finite or infinite set. We all know that the cardinality of set, the number of elements inside the set. And then, if it is a null set, you're going to write open and then close braces. Okay? So, let's say for example, number 1, we have set P. We have elements 25, 50, 75, and so on and so forth, up to 250. So, if you're going to count the number of elements from 25 up to 250, so you have to think. So, we have 25, 50, 75. What is the next number after 75? Of course, you're going to add 25, right? We have 100. Next, we have 125. We have 150. We have 175. 200. We have 225. And the next is that 250. So, let us count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So, since that it can be counted, so we can say that its cardinality or the cardinality of set P is 10. Okay? Because there are 10 elements in set P. Okay. And then we can say that this is a finite set. This is a finite set. Okay? So, let us have number 2 example. Let's say we have set A equals to P, O, W, E, and then R. Okay, so how many elements are there in set A? We have 1, 2, 3, 4, and then 5. Since that it can be counted, so we can now get its cardinality. So, the cardinality of set A is 5, right? And we can say that it is a finite set. Next number 3. Okay, let's say we have number 3. Let's say we have set n equals to 1, 2, 3, 4, and so on and so forth. So, as you can see, can you count the number of elements inside the set n? So, what do you think? Of course not. Okay. So, the cardinality of set n is that is infinity or cannot be determined, right? Or it cannot be counted, or that's infinity. So here we can say that it is an infinite set. Okay? Next number 4. Let's say we have set T equals to, as you can see, that's an empty set, right? So its cardinality is 0. So n of t is equal to 0. So this is what we call a finite set. Okay? This is a finite set. Okay, next, number 5. Let's say, for example, we have set E values of x such that x is an even number. Okay, so can you count all the even numbers? Of course, no. So its cardinality is infinity or cannot be determined. Okay, so of course it is an infinite set. So that's all for today. You know now how to illustrate null set and cardinality of sets. For more videos and updates, please do like, comment, share, and click the notification button. Thank you!